Alright, so I'm going to try to be really quick with this so we can get through it. So solving these equations are extremely similar to what we did last unit. So if you notice the steps, you have to isolate the term, so either the cube or the cube root term, get that by itself first. Then for these cubic functions, we're going to cube root both sides because that will undo the cube, and then we solve for x. Notice that this doesn't say that you have to check for extraneous solutions. And that's because you don't have to. The only reason we had to check for extraneous on square root functions is because we couldn't have like a -4 in our square root because we would have imaginary numbers. And that's not the case now, so we don't have to check because we know that that will work. That's where the whole domain being all real numbers comes into play. So when I do this, all I gotta do is isolate that term. So I'm gonna add 125 to both sides. X cubed equals 125. Now this is all by itself, so now I can cube root both sides. I cube root because that is the inverse operation of cubing, so it undoes it. So now I just have x and then the cube root of 125, which is 5. So that's my solution. Now the next one, I'm trying to isolate this whole thing as the cube term, so I got to get that by itself. So I got to add 8. And I have 2x minus 16 cubed equals 8. Now that that term's isolated, this whole thing is isolated, I'm going to cube root all of that and cube root that. So now this cancels and I just have what's inside, which is 2x minus 16 equals the cube root of 8, which is 2. Now it's just like basic algebra, I'm solving for x. Add 16. 2x equals 18. I got to get x by itself, so I divide by 2, and I get x equals 9. Alright, I know I'm going quick, but I want to make sure I get time to upload this, and the internet here is not that great. So here I have to isolate this because that's the cubed part, so I got to get rid of the 108 and get rid of the 4. So I'm going to add 108. Now I'm left with 4 times 3x plus 3. Oh, that was awful. Cubed equals 108. Now I'm going to divide both sides by 4 to get rid of the 4. So I have 3x plus 3 cubed equals 27. And now that this is isolated, I can cube root both sides. So that gets rid of the cubed, and I'm just left with what was inside, 3x plus 3 equals the cube root of 27, which is just 3. Now I'm just solving for x. So subtract 3, 3x equals 0. Divide both sides by 3. I get x equals 0. That is my solution. Voila. Alright, cube roots. Similar process. Isolate the radical term. So isolate the cube root part, which down here, that's for the first one, that's just that. And then I have to cube both sides to undo the cube root, just like to undo a square root. If we had x squared equals 4, we would square both sides. We'd get x equals 16. Similar thing here, but now it's cubes. So this first one, I'm going to add 7. I get cube root of x equals 9. Now that it's isolated, to undo it, I'm going to cube both sides. So that cancels, and I have x equals 729. So then that is my answer. I do not have to check it. Next one, got to isolate this. So I'm going to divide by 4. Divide by 4. So I get cube root of x equals 6. And now I'm going to cube both sides, cancels. I have x equals 216. I think that's right. Oops. So my solution is x equals 216. Alright, now this one's a little bit more difficult, obviously, but it's not that bad. So I need to isolate the cube root, but you see we have 2 of them. So now all I have to do is move one of them to the other side. So this one's negative, this one right here is negative, so I'm going to move that over. So I'm going to add cube root of x to both sides just to move it over. So now on the left I have the cube root of x squared plus 3x minus 15 equals cube root of 3x, or cube root of x. Now this is like what you guys, a lot of you guys said were the easy ones on the last unit, because all you have to do, because it's isolated, is cube both sides. Now that cancels and that cancels. Now all that's left is x squared plus 3x minus 15 equals x. But now the one thing you got to pay attention to, like with a problem like this, is you have a squared term and a linear term. So that means we're going to have to factor it. So I got to move this over, set it equal to 0. So I'm going to subtract x. So x squared plus 2x minus 15 equals 0. And now I can factor it using my ACB table. So AC is negative 15, B is positive 2. So I have 5 and negative 3. So x plus 5, x minus 3, divide by a, but my a value is just 1. So it's just those two. So my solutions when I set these to 0 are x equals negative 5 and x equals 3. I have two solutions here and I do not need to check them. Isn't that a beauty? And that's pretty much it, guys.